4 different sessions that we're going to be doing over the course of the next month. Pretty much section by section in terms of what's on the MCAT and some strategies and things to start thinking about as far as conquering this exam, mastering this exam, really kind of becoming the rock star of this exam that you need to be in order to get the score that you want, so you can be a competitive applicant, and all the things that are connected to that and all the fun stuff. So I'm excited to be here. I'm excited that you're all here. We're looking forward to the questions that you have. So we've got a chat for you to introduce yourself. So if you want to let me know where you're dialing in from, I know that's an old term. Love to kind of see what our expanse is of where everybody's coming in from. And at the same time, if you have questions as we go through this, feel free to ask them in the question chat. I'll be keeping an eye on it. I'm only one person. I'm a human, so it might take me some time to get to your questions, but we'll get to all the questions as you have them throughout today. So feel free to ask them as you have them, but also know I'm not ignoring you. It's just a matter of managing all the things that need to happen. That all being said, my name is Petros Manassi. I'm the Vice President of Test Prep and Tutoring here at Medical School Headquarters. I have 25 years of experience, actually 26 years now. It makes me feel really old when I say that. Experience in the test prep world, building programs for the MCAT specifically, for pre-med specifically, in terms of preparation and kind of all the things. I've been a teacher, so done all the things related to the MCAT, and really happy to be here at Medical School Headquarters, where our mission is to really democratize this process as much as possible to get the information out to students. And then we also offer services in terms of right now exclusively in tutoring for the MCAT, but coming soon in the middle of the fall, we'll be launching some big exciting news regarding full programming for MCAT preparation. So more to come on that. It's going to be very, very different from kind of the traditional, dare I say, kind of old school way of preparing for the MCAT, where you go to class and you listen to somebody teach a concept and then do some questions. We're going to be doing this entirely the same way they do it in medical school. So nice and problem solving based. So problem based learning is really going to be kind of one of the key elements. But to get things started here tonight, we're going to talk really about the chemical and physical foundations section. I'm going to just call it ChemPhys. It'll be a tongue twister if I have to keep saying the chemical and physical foundations of biological sciences. So it's the ChemPhys section. It's section number 1 on the MCAT. So that's what we have here. It looks like we've got folks from Oregon, we've got New York, we got Texas, East Texas specifically. Jay's in California. I'm in California. Barcelona. All right. So that Julia, that wins. I think so far it's 2 a.m. and you're. So hopefully I'll keep you awake at 2 a.m. So that no pressure on me, right? So we got Philadelphia, Dallas, Nebraska. We've got New Orleans. I was actually just there, so awesome. South Carolina, Milwaukee. I've been to Milwaukee. I've been to all these places. It was great. I've even been to Barcelona. So that is that. That being said, if you have questions, as I said, let me know. This is a session for you. I can talk about the MCAT all day long, so stop me and ask the questions that you have. So really what we're ultimately looking at as far as the progression of your preparation for the MCAT, really, if we think about these two triangles, so these are these two conjoined triangles that are here for us. If you think about the left-hand side as being kind of the beginning, right? So when you're starting your MCAT preparation, more and more of your time is going to be spent, or more of your time is going to be spent in a necessity reviewing content. Right? You got to get solid on the content in order to be successful at this exam, right? You can't go in and say, oh, I'm going to figure it out on the day of the exam. You have to be absolutely solid as far as the content, but you also need to start developing your critical thinking skills, right? So the critical reasoning, the critical analysis skills, those are going to be imperative for you to be developing. One for the cars section, which we'll talk about next week, which has no science on it, but the critical thinking skills, the analysis skills, those reasoning skills, those are omnipresent throughout the entirety of the exam. So if you don't build those and you don't do those kind of early on and get strong at them, you're going to struggle. I can't emphasize that enough. At the same time, if you get stuck in content review and you're only reviewing content and you're feeling good about yourself because you keep reviewing this content, you're like, yeah, I'm learning this. I hear this all the time from students. So I'm doing my Anki decks. I'm, reading my textbooks or reading my review notes. Like, great, good for you, but that's not going to reward you at the end of the day. The MCAT never will reward you simply for knowing information. It will only reward you for being able to apply the information, which is why you have to slowly start to incorporate practice of application, practice of taking questions, and then building your endurance skills, right? It's not good enough to just be able to say, yeah, I can get questions right. You have to be you've got to be getting questions right in a certain amount of time, right? And you're going to have to get questions right and keep getting questions right? I mean, there's, more than 50 questions on every section. So you have to, and then you have to rinse and repeat, rinse and repeat, rinse and repeat. So those skills also need to be developed. I mean, I have conversations with students all the time who say, yeah, I'm doing really well with the questions, but when it comes to the test, I'm finding myself to be exhausted. It's because you haven't built your endurance skills, right? So there's all those elements that need to get kind of unpacked as far as your preparation is concerned as you're moving through this. So this is a progression of time. Where the start line is, where the finish line is, that is obviously dependent on when you're planning on testing, when you're actually going to be able to start your preparation in earnest. So I haven't put any dates on here per se, but this is kind of generally what's going to happen is your content review is going to need to taper off because you're going to be improving and increasing your application practice and endurance skills, right? So it's kind of this little bit of a constant adjustment that's happening. If you get stuck in the content review, then what's going to happen is you're not going to give yourself enough time for the actual practice. If you only are doing practice questions, you're not going to have enough time for the content review. So you have to find the good, delicate balance between that. As you get later in your preparation, more and more of your content review will only be dictated by your performance on practice questions and eventually on practice exams, right? So this is, this is all kind of all part of it and all something to be considering and to be thinking about as you're looking through this kind of process and really planning things out and making sure that you are finding that right balance and also, quite frankly, finding the time to do all this, right? The worst thing you want to be doing is trying to do too many things, right? You don't want to be studying for the MCAT and volunteering 15, 20 hours a week at a clinic so you get your clinical experience and taking 3 really hard science classes and doing this right? I mean, you have to make sure that you're balancing it. So scheduling, timing things out, finding that balance is going to be absolutely key. And that's not just true for the Chem Phys section. That's true for all the sections, right? That is a across the board kind of thing that you have to be ultimately looking at. If you have questions about that, feel free to bring those in. As far as the MCAT itself is concerned, 4 sections, right? I won't get into the nitty gritty of the sections just yet. We're going to get into the nitty gritty of the Chem Phys section. Again, it's the chemical and physical foundations of biological systems, so you don't need to keep saying that every time. We're just going to call it Chem Phys, call it CP if you want to call it that for short. But the key with these sections is, one, yes, there are breaks in between them, but they are long, right? I mean, this is literally like taking 2.5 finals in one day. So this is an endurance exam, right? There is an element of endurance that has to come into play, that has to be there, that you have to train yourself for and build yourself up for. But the other thing to take note of, aside from the critical analysis and reasoning skills section, the CARS section, all 3 sections have the word biology in them, right? The other 3 sections all have the word biology in them. This is where the MCAT gets kind of complicated and is a little bit different than how we have learned things as undergrads. As undergrads, we learned in very isolated systems, meaning when you were taking chemistry, you were being taught by a chemistry professor who wanted you to become a phenomenal chemistry student, right? That was their goal. They weren't thinking about the physics. They weren't thinking about the biological applications of the chemistry that you were learning. And the same is true for physics, and the same is true for biology. And when you're learning bio, you're not thinking about the physics that's involved in the biology or the chemistry that's involved in the biology. You're learning the biology. But all the sciences are integrated, just like the human body is integrated. Surprise, surprise. And on the MCAT, they are integrated, and you're tested on them in an integrated manner, right? So as we kind of build through this series, these next 4 weeks, essentially, you'll see what I mean by this. Today, we're going to kind of start small as far as Chem Phys is concerned. I'm just going to show you a couple things just to get your minds kind of thinking through about this. And then you'll start to see what I mean by this as we kind of go through this progression. But the integration of the sciences is something that throws a lot of students off guard the first time they look at the MCAT. I mean, my favorite one is if there's a passage that's it's about a biological system, but then they're asking you all these chemistry questions, and you're like, what does this have to do with biology? Like, what does it have to do with chemistry, for that matter? But it's all connected, right? You think about my favorite example is the circulatory system. The circulatory system is a biological system, but it's got crazy amounts of chemistry in there, right? I mean, your blood is acting as a buffer. You're moving chemicals around. There's a pump involved. It's called your heart, right? There's fluid dynamics that's going on, right? There are all these things that are happening at any given time that really are all so interconnected. And because we've learned them in such isolated manners, it becomes kind of this moment of, oh, I need to start thinking differently about these sciences. And that's what really trips a lot of students up, right, as they're preparing for the MCAT, especially in the earlier days, if you will. As far as the Chem Phys section is concerned, as far as the content is concerned, this is the breakdown. This is from the AMC. So this isn't, my guess. This is literally from the AMC website. So, I mean, that's the source, right? They're the ones who write the exam. This is what they're saying. They're saying that on the Chem Phys section, 25% of it will be biochemistry. There'll be some intro bio in there. There'll be GChem. There'll be OChem. There'll be introductory physics. You might say, well, wait a minute. What does OChem have to do with all this? I thought OChem was more biochem. Well, it is, but it's all connected, right? So the biochemistry relies upon the organic chemistry. It also relies upon the chem, right? The biology relies upon biochemistry. Physics, there's physics in biology. It's all going to be one big happy party, if you will, as far as the physical sciences are concerned. So you have to get ready for it, is what it comes down to. I'm not saying don't study biology when you're studying the Chem Phys section, because that would be a lie, right? There is the necessity to understand the biology behind things. What you won't see here today, but you'll see it when we talk about the biochem section, is even in the biochem section, 25% of it or so is biochemistry related. So, and then there is general chemistry, but it's at a smaller quantity, and right. So everything is all there, kind of as you're going through. So every single question, every single passage on the MCAT is going to be covering and requiring you to understand certain areas of content. Remember, I said earlier that just knowing content is not good enough for doing well on the MCAT, right? It's about really being able to kind of bring all these pieces together. The reason for that comes down to the fact that the way the MCAT is actually designed as an exam, and I've spent more hours looking at the kind of design of the MCAT than I care to admit, right? But the reason why it's kind of the way that it is that every single question, every single exercise they're having you do is at the intersection of a content category area. And they list out all the content categories. So you can go to the AMC website and see what those content categories are. And one of these 4 skills, right? So every question is going to be testing you on some content and on one of these skills. So it's either the knowledge of scientific principles, scientific reasoning and problem solving, the reasoning behind or about the design and execution of an experiment or of research, and then statistical reasoning. And then overall, there's kind of math skills that are also involved. So you put those two together, and this is really how you have to start training yourself for these questions and training yourself for this exam. It's a game like anything else, right? You have to train yourself to become really, really good at the game. And the better you're able to play the game, the better you're going to ultimately execute as far as the game is concerned. So this is what we see as far as the breakdown for the Chem Phys section, right? As far as these 4 skills are concerned. The 4 skills repeat themselves in the other sections, but sometimes with slight different variances as far as those percentages are concerned. So there is a heavy amount of scientific reasoning and really just understanding the scientific principles as you're going through this, which then kind of leads us into this conversation of how do we manage this, right? And here's part of the problem, and tell me if this is you. We oftentimes take general chemistry as one of the first courses that we take in college, right? I mean, it's literally, most of the time, Chem 1A or Chem 101 or Chem whatever it's called, that's the first class that you're going to be taking in the pre-med track. And part of the reason is because it's part of a sequence, right? There's the intro chemistry, then there's the OChem, and then there's the biochemistry. You kind of have to go, that one you have to go in order, right? You can't learn it out of order. You can't take biochem and then take general chemistry or then take organic chemistry. You won't be a happy person really at the end of the day. That all being said, it's the reason I say that is that it's oftentimes the one that's the furthest away from you when it comes time to start preparing for the MCAT. Sometimes with physics, I've spoken to a couple students actually this week, this was their case, and I hear this a lot, is that you haven't done the second part of physics yet, right? So there's also sometimes a content gap that you have to fill before you start actually preparing for this exam. So with all that said, as far as so Naomi, the website it's what's on the MCAT. I think it's like 21 pages, 22 pages. So it is a lot is what it comes down to. You don't have to read the whole thing. Definitely not. We're working on getting some summaries of that put together. So we'll have that soon as well. But yeah, it's a big document. The best place I would take you to is not the PDF, but on their actual website. You can click on, they have one page that's like the four different sections. You can click on that and it gives you a little bit a better summary. The PDF is hey, we've told you everything, right? Everything's fair game because we gave you all the info. So they've covered their bases as far as that document is concerned. But yes, it is quite a long document for certain. So when we're looking at kind of how to study for the Chem Phys section, really it comes down to these 3 core principles. And they're simple principles, and they're, and I simplified them for a reason. You need to learn the fundamentals, right? You need to learn the fundamentals or relearn the fundamentals depending on kind of how far away this is in your memory. The problem with reviewing content and just learning the fundamentals alone is that you don't retain them, right? Part of the reason why we forget the things that we learned in that first class that we took, 3 years ago, 4 years ago, whatever it might be, is because we haven't been using them. So the second stage of this is you have to practice what you've learned, right? So you've learned something, and then you have to practice using it, and that's really where practice questions will come into play. That's really where your, passages as you're taking practice exams will come into play. But then you have to start to revisit what you learned. And by revisiting what you learned, I don't mean reviewing it. I mean thinking about it in the more interconnected way, right? Thinking about, okay, that concept that I learned over there, where else is that also true, right? Or where am I seeing real life examples of this in my own personal life that this is actually applicable, right? And I can be thinking about how all these pieces are in fact connected to each other. So that's going to be a key part of your preparation, is really kind of thinking outside the box, right? Not thinking, oh, this is just PV equals nRT, thinking, okay, this is PV equals nRT, but we're now looking at this in terms of, lung pressure and how much, air is coming into lungs and how the wasted air is expelled, right? This is where you have to start thinking about the interconnectedness of things. And I think that's where kind of a lot of the prep that's out there really falls short, is that it doesn't do a great job drawing the connections between things. It doesn't do a great job of really making you think how this all ties together, right? How this is really all, in a weird way, one big happy MCAT family, right? So that's the key to kind of be thinking as you're going through these things. So that's kind of part one. Part two of all this is this notion of interleaving. And there's a great article. I have the title of it for you on the next slide, so you can go check it out. But one of the mistakes, especially with the physical sciences, that happens is students think, okay, and tell me if this is you, right? Or maybe you don't want to admit that it's you. It's okay if it's you, is what it comes down to. Where you think, okay, I'm just going to go review all of the thermodynamics. I'm going to go review all of the, I don't know, phase changes. Now I'm going to go do all of the electrostatics. I'm going to go do all of this. And you do these things in kind of these chunks. But what ends up happening is by the time you have like finished the second chunk, you have forgotten all the things you learned about in the first chunk, right? So if for instance, if I were to review all my thermodynamics first and then never really look at it again, then I would have forgotten it by the time it's time to go take the MCAT or by the time I'm taking a full-length or practice exam. So the concept of interleaving, and this is a very simple way of thinking about it. If I have category A, category B, C, and D, and I do all the A stuff first, and then I do all the B stuff before I can move on to the C stuff, before I move on to the D stuff, et cetera, et cetera, et cetera, what ends up happening is you end up forgetting the material from kind of the older sections, if you will. So what interleaving is, this is a learning science tool. It's a model that has proven itself to work, and it works really, really well for the MCAT. Trust me on this when I say this. It's the way that you have to kind of space things out. The idea here is that you want to kind of do a little bit of A, do a little bit of B, a little bit of C, a little bit of D, then go back to A, then go back to B, then go back to C. So what's happening now is it's always all staying fresh on your mind. If you go to the gym, which I probably should do more of, it's the same concept, right? You're not going to work only on your arms for like 3 months and then work on your legs and then work on your core, right? And then do your cardio. You kind of mix it up, right? You do a little bit of this, that. Now, part of that is because your muscles get tired, but your brain's a muscle, effectively, right? You're learning this material. So great article. It's a pretty quick read. I think it's like a maybe a 10-minute read if you want to kind of do some analysis. It's from 2015, but it's 100% still relevant and reliable. Like there's nothing new that's changed about how our minds operate. So it's a great article. I would encourage you to take a moment and read it and kind of get yourself familiar with this idea of interleaving, because that will help you start to think about how to build out your study plan, right? And how to build out your schedule. The way that, today we offer tutoring services, this is how our tutors work, right? Our tutors are working with students to build out their study plans, but more importantly, they're working with students to make sure that they're kind of guided in their approach as far as what to do first, what to do second, what to do third, et cetera, right? So this is kind of part of the expertise of learning how to study for this exam, is also knowing how to build out your study schedule and how to kind of get all the things in the order you want them to be in. So that's the concept of interleaving that I think is important for you to take into account. I feel like at any session for the MCAT, one needs to see a nice little lion cub, right? So here's a lion cub. We're going to call him Leo, and there's a reason we're going to call him Leo. Who's heard Leo the lion says grr? Give me a thumbs up or a yes. I've heard Leo the lion says grr back when you were taking chemistry and maybe even physics, right? So good old Leo the lion says grr. That's a mnemonic. That's maybe you learned oil rig. I prefer Leo the lion says grr. So here's Leo, right? Leo the lion says grr reminds us that the loss of an electron is oxidation. The gain of an electron is reduction, right? Here's the thing. we learn Leo the lion says Gur, and loss of an electron is oxidation and gain of an electron is reduction, usually in a chemistry class, right? That's the usual kind of place that we normally learn this concept. And we think about it in a very, very isolated way. We think of it as a chemistry concept. So, if I gave you a question like this one, right? You've got a galvanic cell, you've got zinc is a half cell, you've got copper as the half cell, you're given the standard reduction potentials, and I ask you, and this is a very simple question, right? So this question is not here to like challenge you per se. It's not here to, teach you a trick in any way. This is a very simple question for a very deliberate reason, right? They give you the reduction potentials, right? They say the reduction potential for the half cell of the copper is 0.34. The reduction potential for the zinc is negative 0.76. And they ask you what's the standard potential of the cell. And you can scratch your head and think, okay, I know how to do this, right? I know that the one losing the electrons is getting oxidized. The one that's gaining the electrons is getting reduced. Since I'm looking for the reduction potential of the cell, I want to find the one that's going to get reduced. So here's the pop quiz for you. Between these two, between copper and zinc, who's the one who's going to get reduced? Just looking at the numbers, looking at the information that's there. Don't even look at the answer choices just yet. Just like looking at the numbers. If you've got copper and you've got zinc, who's the one who's going to gain all the electrons? Who's the one that's going to come and say, give me the electrons, give me the electrons, let me get them from you. Who's going to win? Got a vote for copper, got another vote for copper, got lots of votes for copper, and you're all correct, right? So copper is the one that's going to win. And the reason we know it's going to win is very, very simple, right? There's no like magic pill here, magic sauce, secret sauce. It's because it's got a bigger number as far as its standard reduction potential. It's at 0.34. The other one is at negative 0.76. So if you put copper and you put zinc together, I can assure you that over time, the copper is going to be taking electrons and it's going to be taking away from the zinc. Right? The zinc's going to be losing their electrons, which is part of the reason why I never want to put copper and zinc next to each other. Unfortunately, some car manufacturers don't know that, and they put the two together, and then you end up with lots of problems trying to get bolts off, right? So it's not a great idea, is what it comes down to. So here's how you would solve this problem, right? You'd use a formula that you've all seen before, and I'm going to give you a little bit of a trick here. I don't even know if this is a trick. It's more of a, hey, your chem professors were wrong. Sometimes to make it look like it's easier, chem teachers will say, oh, take the reduction potential of one and then flip the reduction potential of the other one and add the two together. Has anyone ever heard that version, right? Say, take the one that's getting reduced, flip the value of the other one, and add them together. And they say that to you to, quote unquote, make your life easier. But in fact, they're making your life more difficult because you have more points of failure, right? One of the things on the MCAT that you want to try to minimize, and especially there's a reason I'm saying this in this session here today, in the Chem Phys section, is you want to minimize your points of failure, right? So points of failure is an idea that is an engineering concept, but the idea is that if you've got to do 100 things, if you can do it in 5 things, then you've minimized the mistakes that can happen along the way, right? So we try to minimize the points of failure when it comes to the MCAT as well. So let's make it our life simpler. The proper formula actually is to say that the reduction potential is equal to the reduction potential of the thing that's getting reduced minus the reduction potential of the thing that's getting oxidized. So in this case here, it'd be 0.34 minus negative 0.76, which turns out to be positive. So you can say, okay, well, 0.34 plus 0.76 or 34 plus 76 is going to be 1.1, and that's your answer of answer choice B, right? And you get the question right. That's how we learned about reduction the first time. But then you get to biochemistry, and you start hearing this term, oxidative phosphorylation, and you start hearing things like, oh, it's getting reduced, it's getting oxidized. And I don't know about you, but sometimes we think, oh, this is something completely new, and it's right. It's this whole new thing that I'm learning. In reality, it's the exact same thing, like literally, right? Oxidation reduction is just or redox. It's just the movement of electrons, right? I'm not trying to simplify that. I'm not trying to trivialize it, but that's really all it is at the end of the day. It's the movement of electrons. So we're moving an electron from one place to the next. There's no reason for when we see this that we should be thinking any differently, right? This is literally the same thing, right? NAD plus, 2 electrons plus a proton becomes NADH, right? That's not magic. That's just the science that's there. So this is where you have to start thinking, okay, I've seen this before, right? I know this stuff. We've got the NAD plus is gaining electrons, so it's getting reduced. The NADH is losing electrons. It's getting oxidized. So this is where that interconnectedness of things comes into play, right? If I gave you numbers, you could plug those numbers in and figure out reductions is what it comes down to. So the idea here with the MCAT, especially in the ChemPhys section, is that there are really kind of these finite number of core principles that are going to translate into other places, right? Same thing happens in the physics side of things. When we learned about force and we learned about gravitational force, right? We learn about gravitational force. Usually the examples are, you got an object here and an object here, right? You got a planet and you got another moon or whatever, and you got a distance between them, and what's the gravitational force between them. And then you get to electrostatics, and the formula actually looks very similar because it is derived from the same place, but instead of using masses, they're using charges, because physicists are lazy and they're like, well, I don't want to be figuring out the little tiny masses of these charges. I'm just going to use the charge and figure out what that electrostatic force is. It's the same thing. Force is force, right? Torque is torque. So whether I'm looking at it as Newton meters or I'm looking at it as foot pounds, it's still torque, right? And torque is work and work is energy. So really at the end of the day, you're looking at the exact same thing. So the more you're able, and this is where it's part of, just to kind of give you a sense of why we're doing this series, right? This isn't meant to be, let's just do a whole bunch of practice problems. I want you to start thinking differently about how you're going to actually study and approach this stuff. Start thinking about how you can better compartmentalize the different topics that are kind of scattered in all these different places, so that as you're studying one thing, you're being more efficient and studying multiple things at the same time, right? This is this notion of efficiency over kind of just this necessity to be in front of a computer screen and watch videos or whatever it might be, right? So really the better you're able to compartmentalize things, the better it's going to be for you in the long run. Okay? Got questions? Type them in. I haven't seen a question yet. Usually pre-meds are full of questions is what it is. So ask them as you have them. That being said, if you came to, was anybody at office hours this morning? Or it was morning for me. Maybe it was afternoon for you. We were at our MCAT office hours today. I promised some things. I want to make sure that we do it. So when you're looking at the physical sciences, it's really, really easy to get caught up in one of the biggest time consumers, and that is calculations. Okay, so on the MCAT, calculations are a huge kind of time consumer. And it's so easy to kind of get caught in this world of, okay, I gotta solve this out, and I gotta solve it the way that I've done it for my chemistry class or my physics class. Problem is, you don't have a calculator. Kayla, I'll get to your question here in a second. You don't have a calculator on the MCAT. So there has to be a better way to be able to solve for these questions, right? That's really where you have to start thinking about it. Sometimes it's as simple as conceptually understanding something and looking at the relationship, right? How one thing is relative to another. If you know that the starting value is X and you know that the value is going to increase and there's only one answer choice that is greater than your starting value, that therefore must be the correct answer, right? Or maybe you know that it needs to increase. There's one that's more and there's one that's like way too much more. The one that's more must be the correct answer, right? So the better you can think about those kind of conceptual and relationship pieces, the better you're going to be in the long run. Now, Kayla asks a good question. There's so many equations. How do you remember all of them? And, like, what do you do? So here's the trick with equations. The worst way that you can practice memorizing those equations is to try to sit down and memorize the equations. The best way to learn them is to actually do practice questions, because the act of doing the practice questions will force you to make them basically second nature for you, right? That's the that's really going to be the key, is what it comes down to, is making sure that they are second nature and making sure that you are kind of retaining them through practice as as you're going through. Unfortunately, Kayla, the reality is that you may only end up needing some of those equations on your test. But the MCAT is very forthcoming and says, here's what's fair game. So you do need to go into the exam ready to do anything, ready to use any and all of the formulas that might be presented to you. So unfortunately, there's no workaround on that one, is what it comes down to. Thomas, as far as interleaving, right? It really comes down to planning things out, and I would say, maybe one chapter, right? Not more than that. Maybe it's even half of a chapter, because sometimes depending on the chapter, depending on the topic, there might be so much that's covered in a given chapter in any of the review books that are out there. So, really being able to kind of boil it down into, very, very specific topics is going to be a big part of it, is what it comes down to. So that is the key. If you got more questions, bring them in. Hopefully those have been answered, or those are good. If you need follow-ups, let me know. So who wants to see your shortcut? Said no one ever, right? So who wants to see a shortcut? Because I got a short. Maybe you've seen this before, right? I'm not claiming this is necessarily the first time you've seen this, but it's a key one, as it were. Regarding interleaving, would this be with only one section, or no? It would be all the sections. So Sasha, I'm talking like, you do something about learning and memory from the behavioral sciences, then maybe do the next thing is oxidophosphorylation, then the next thing is something from cars, and then the next thing is something from chem phys, right? I mean, you want to be addressing all the things very, very slowly. At some point, you're not going to need to review topic X from the chem phys section, so maybe you only come back to that once every couple weeks, right? But the idea is it's much easier. I mean, let's be frank. It's much easier said than done, right? Like, I don't want to overly idealize this and make you think like, oh, to be a walk in the park, I can just go and do this. I mean, everybody tries to make it seem that way. But the idea is that you want to keep the material fresh in your mind. The last thing you want to go into is like a couple weeks before the MCAT, and you go, oh yeah, I haven't looked at thermodynamics in like a month and a half, right? That's not going to be good news for you. So that's the idea behind it. Cool. So, got a couple of please show me this thing that you're probably overly talked up at this point. So here's one thing that happens. There's there's these things called pHs, pKas, right? POHs, right? All the things, right? All the P's. So this is what we call the P trick. And this one's easy to remember because my name is Petros. Some people refer to me as P, so this is the P trick, is what this is. So you'll never hopefully forget this. So here's the P trick, okay? The P trick is, and I know that sounds far worse if taken out of context, right? We're talking about the P as far as the negative log. The negative log of anything, or the P of anything, is always the negative log of whatever that anything is, okay? If the following parameters are true, you can use this to approximate any p-value, right? pH, pK, pOH, whatever it might be. If the anything is expressed as m times 10 to the negative n, and if it isn't expressed that way, you can't express it that way, right? That's part of putting things into scientific notation. And the m is a value between the number 1 and 10, and the n is an integer, right? So if we've got m times 10 to the negative 5, right? We got 5 times 10 to the negative 5, for instance. Then the p of that is going to be the value of the n without the negative sign, right? So it's m times 10 to the negative n, but we're just looking at the n value. So for instance, if it was, m or 5 times 10 to the negative 5, we're just looking at the 5. You take the n value, and from it, you subtract whatever 0 point whatever the m value is, and you'll end up with the pH. It works every single time. If the m has got a decimal place in it, just get rid of the decimal place, right? So if the decimal place is 1.5, right? If m is equal to 1.5, then it would just be n minus 0.15, right? You don't have to worry about you're not going to end up with 2 decimal places. So this works every single time. And this will allow you to get a pH that is close enough to one answer choice, and you get that question right. Because you don't have a calculator, you're not expected to memorize the logarithmic table, right, is what it comes down to. So keep that in mind, right? Practice it if you want. I mean, here, I'll give you one. 7 times 10 to the negative 8. What's the pH going to be? While you're working on that, Julie, I'll answer your question. For the interleaving, I think I kind of answered that earlier, but I'll say it again. The idea would be, and I think Artie, you asked the same question. So maybe I just am seeing this is what it is. I'll answer it again. The idea is that it's like topic to topic. So I wouldn't even use the chapters, because chapters will have multiple topics built into them. So, the key, right, is to say, okay, I'm looking at this topic, now I'm jumping to a topic. So maybe I'm looking at a topic in chem, jumping to a topic in bio, then a topic in behavioral sciences, then a topic, right, going back and forth as you're going through. So it's the topics. That's what it is. Okay? And as far as the answer is concerned, what answers do we have coming in? You can all put your answers into the chat. So we got 7.3. You're absolutely right? 7.3. So you say the n value is 8, right? The m value was 7. 8 minus 0.7, 7.3. That works every single time. It will never not work, is what it comes down to. So that's a bit of a time saver, right? This is not the only thing that's out there as far as time savers, right? There's lots of different ways to save time on the MCAT. One of the best ways to save time is to always try to use, this is a personal opinion, but I have seen it work better than I've seen the other ways work. So there's Boyles's law and Charles's law. Everybody remembers those, right? But really all of those come from PV equals nRT. So generally speaking, just use PV equals nRT, right? If you try to go, let me see, should I use Boyles's law or Charles's law? Just use PV equals nRT when you're drawing comparisons between pressures or temperatures or volumes, right? Just always use PV equals nRT. My starting pressure, my starting temperature, my starting volume, my ending pressure, my ending volume, my ending temperature. I'm trying to solve for one of them. You find a ratio, you end up with the answer, right? Don't try to necessarily dive into, figuring out. It's again one of those points of failure, right? Stick to the core formula. it all originally came from, as it were. Okay, so that's that there. I've mentioned our services. If it's something that you are looking to do, we're now starting to work with students for the January exams. We've got a couple students that we've recently, in this last week, we're preparing for the September exam who came to us a little bit later. If you're testing for, one of the August dates, we can help a little bit, but there's not that much time that's left, right? So all that. So if you want to find out more about our services, then eventually when we full launch our big classes, that's our website. So you can hang on to that QR code. You can also schedule, if you're thinking about using one of our services, schedule a consult call with me. We can help you figure out kind of which one's going to be right for you as far as the different tutoring packages that we have. So that all being said, I'm going to open it up to questions that you have, and we'll take it from there. So, what's on your mind is what it is, and let's use the ask a question one, just so that I don't have to keep flipping back and forth and miss questions. Kayla, how would you approach meteor passages? I'm going to interpret what I think you mean by meteor, but tell me if I'm wrong. By meteor, I'm assuming you mean passages that are like full of details, lots and lots of words, lots of intricacies and such. Generally speaking, with passages, you always want to be reading for purpose. You don't want to get bogged down in the details. If you need the numbers from the experiment or from the table, they're there for you when you are answering the questions. In the physical sciences, there's oftentimes lots of passages with tables, and it's really easy to find yourself trying to over analyze the table before you even get to the questions. So the rule that I tell students all the time is let the questions dictate to you what you need, what work it is that you need to be doing. My mantra when it comes to the MCAT is be efficiently lazy. Do the work you need to do to get to the answer and the result that you're looking for. That's true when you're studying. That's true when you're taking the test, right? It's true in all the things, right? Why do extra work when it's absolutely not necessary? It's part of the reason why this is a personal thing. I do not like people who just want to look busy all the time for the sake of being busy. I'm like, not that I don't like them. I'm not a mean person, but I'm just like, why do you just keep making yourself look busy when you could be doing this thing much more efficiently, right? Don't create work for the sake of creating work. Do work to see what the outcomes are going to ultimately be. So that's the case. That's the case there. So same is true when it comes to the MCAT. So hopefully that answers your question. If not, shoot me a follow-up as we go. Other questions that y'all have? Did you have fun? Was this enjoyable? You can say no. I won't. My feelings won't be hurt. Matthew, I do not recommend reading the questions before the passages. If I had $1 for every time somebody asked me that, I'd have like $5 now. The reason why you don't want to read the questions before you read the passages, it actually costs you more time in the long run. So please don't. There's this kind of falsity out there that, if you read the questions first, then you'll know what to look for in the passages. One, you have to physically click through the questions, and you only see one question at a time. So that literally takes time. And then by the time you go and read the passage, I would bet that you would not remember all the questions that they've asked you. So no. So generally, you do not want to be doing that. Sometimes it's okay to read the answer choices before you read a question. Namely because if you look at the answer choices, you might see, okay, I'm going to have to do a calculation for this question, or I have to go back to the passage for the question. But generally speaking, not going to be the case. Sophia has a good one as far as improving timing. So there's a misconception out there. I was actually having this conversation earlier this week. There's a misconception out there that, I have timing problems, right, with the exam. And the answer is yes, you do have, it is possible to have timing problems. But it's not that it's a timing problem per se. The timing problem is a manifestation of other things. right? So what I mean by that is it's either, and this is where you have to kind of do so Sophia, to answer your question, what you have to do in order to fix the timing problems is figure out where is it that you're eating up too much time. And I think you kind of already did that, right? You take long on the questions and vice versa, right? So if you find yourself taking too much time in the reading of the passages, that means you have to train yourself to read differently. And I'm going to say like read better, but I don't mean you're a poor reader. I just mean read more efficiently, meaning just read for the purpose. Don't get bogged down in the details. Don't let the distracting words get to you, right? Look for the keywords that will allow you to, to pull certain things out, et cetera, et cetera. If it's in the questions, maybe you're taking the long path to answer a question, right? You're doing the long calculation and not looking at, oh, I know the pressure's going up, so the volume must be going down, right? So like you're not looking at those relationships, the conceptual connections that are there as you're working through. So that's improving those things. And it's really about shaving seconds off of each question, and then that will start to manifest into bigger and bigger points, as it were. Okay, so that's going to be the key with that one. When you're doing content review, you read a section and then answer the questions. Tell me what an FSQ is, because that's not popping in my head what that represents right now. Just let me know what it is. Or maybe find this MSQ and okay. And look at the section we need more help in. I think generally speaking, you do want to do reinforcement questions on the topics that you've reviewed, right? So that's going to be key, because that's going to help you with the retention. Yeah. Jay, as far as not having a calculator, yes, by definition, since the test does not give you a calculator, they are not going to give you answer choices that are so close to each other that you have to precisely freestanding. Sorry, it's been a long day, so my mind only works for so many hours. Yes, freestanding question, discrete questions, standalone questions. Yeah, so yeah, I mean, absolutely find those questions, get the reinforcement as it were. So Jay, in terms of the answer choices, they are deliberately written in a way that you don't need to be getting precise numbers as you're going through. As far as whether or not it's worth jotting a few words summary at the end of each paragraph, yes. It's not so much a summary; it's you want to jot down kind of what the purpose was of the paragraph, right? Why did the author write it? That's the question that you're answering to yourself, is why did the author write this paragraph? They wrote the paragraph to give me the experimental results. They wrote the paragraph to show me the mistake that was made by the chemist, right? Whatever it might be. For the ChemFist section, so Rayan, I'm going to say this. It's not directed at you, but just since you said it, I'm going to say it. You're going to hear a lot of people say a lot of things. You have to find what works for you, is what it comes down to. So, yes, you could potentially answer a question without reading the passage. Those questions are what are referred to as discrete questions, that are passage-based discrete questions, which effectively means they are a question that could have been a standalone question that just happens to be on the topic of the subject, so they threw it in there. So, yes, there might be a question that you might be able to do that. General advice from my experience, from the outcomes that I've seen of students, from the research I've done, from the work that I've done, the programs that I've developed through the years, read the passage first, make a note as far as why each paragraph is there, what was the purpose of each paragraph, and then go to the questions. Okay, so that's the key. So we already addressed that earlier. I'll say it again. Like that's how you have to approach it. That's the key. What does the fundamentals review look for Petros? How do I set up a review section? Not sure what the question is there, Omid. Maybe if you can clarify that would be great. As far as the fundamentals review, the fundamentals review is the fundamentals as far as the core content, right? So like, if you need to know about thermodynamics, you first need to learn what delta H is and what that actually is representing before. All right, so here's an example for you. You need to know what delta H is and what it's representing before you try to understand what Gibbs free energy is, which relies upon delta H, right, and what it means. So when I say understand the fundamentals, I mean, don't just memorize, the formulas. Understand what is it that I'm actually looking at as far as enthalpy? What is it that I'm actually looking at as far as Gibbs free energy? How are the two different from each other, right? So really knowing what those key fundamental differences are. And if for any questions that have come through, if you need more clarity, by all means, let me know. If you have follow-ups, please let me know on that. I think there were some questions that came in over here. Oh, a couple of you found this helpful. Well, that's good. I'm happy. So hopefully that's a good sign. So anyway, we've got a couple minutes, so we'll take any final questions that you have, and then we'll wrap it up. No, Julia, that's for all, for reading passages, that's for everything. That's for cars, that's for Chem Phys, that's for anything that has a passage, right? It's for all of them, that's what it is. You're going to be finishing up biochem and then take the MCAT. It's on how long I should take to prepare after finishing that class. Generally speaking, you're going to want to spend about 300 total hours studying for this exam. That can translate to about 4 to 5 months. So depending on when you're going to be finishing up biochem, I'm assuming that's the end of fall. Maybe you test in like April or May, right? Because you can start studying for the MCAT before you finish up the biochem. You'll just, that'll be kind of one of the key areas to be looking at, as it were. Matthew, I think I answered that question. I hope maybe you didn't hear the answer. Hopefully you did. I'll answer it again. Yes, it is worth jotting a few words, but the key is to be writing down the purpose of each paragraph, as it were. Mukund had a question, but you brute force through questions rather than studying concepts. No. So do not do that where you just go straight to questions. You need to do some content review. Now, you can do some questions to figure out what content you need to review. That's fine, but I wouldn't say just like dive straight into things. Yes, you'll all get a recording of this. So Maria, you'll get a recording. If you register for the event, you'll get a recording of this, so you can watch it as many times as it were. Matthew, okay, so you missed it. All right, so I'll say it again to make sure you hear it. As you're reading the paragraphs, jot down the purpose, right? Like, why did the author write this down? Like, what were they trying to convey to me? Was it they want to tell me the results of the experiment? They wanted to tell me what was wrong with the experiment, right? That's the key there. So that's the key. That's the way to look at it. Hopefully you heard it that time. If not, shoot me an email. That's what it comes down to. Yankai, as far as the test dates are concerned, historically they release the test dates in September, and those test dates come out usually right around the time that the current year's test dates are winding down. So that's when you should expect that to happen. Pega, we haven't formally put out how the class are going to work, but we do have tutoring services right now. So if that is something that you're looking at, by all means, be in touch. As far as the classes are concerned, though, it will be a full comprehensive course preparing you for the MCAT. It will include, it will be problem-based learning as far as what you're actually doing in the class sessions. So, more to come in that regards once we make some more formal announcements on things. As far as plateaus are concerned, Kat, I would say you got to keep working. And really identify what is it that's causing the plateau, right? Is it a timing issue? Is it that you're always you're getting it down 50-50 and you're not, you're choosing the wrong one? as it were. So that's going to be the key. Joshua, good idea to make your course load light during your biochem class. So that's not a bad idea at all. So no passage today. So that's it. And registration will open for the January exams in October. That's when registration, unless they change something this year, as it were. That being said, thank you all for joining us here tonight for this first one. We will continue the series next week with cars, where we will be looking at passages, because there's cars a very passage-based section and such, and we'll be talking about passage strategy and such there. So we'll see you next week. Hopefully you can join us. If not, check out the recording after that one comes out. All right? Have a good night, everybody. Thanks for being here. You're all very welcome.